Hello, everyone. We are back for Chapter 2, Part 2. So this is going to be covered in a couple of different videos. That way you can find what you're looking for just a little bit easier. But for this part of Chapter 2, we're going to talk about the periodic table, why it's arranged the way that it is, kind of where all of this information comes from. Talking about, different information you can gain from looking at the periodic table, as well as ions, what they are, and give some examples of how to figure out how many electrons are in an ion. We'll also talk about isotopes. So we'll talk about how to identify isotopes, what they are, and then how to identify the number of neutrons and protons in a specific isotope. And then we'll finish up talking about atomic mass. So this video is just going to cover the periodic table location stuff, and I'll post videos about the ions, the isotopes, and the atomic mass information as well. So let's get cracking, y'all. So why is the periodic table like the periodic table, right? So you can find different versions of the periodic table out there. I know there's like a really, really cool spiral version where all of the elements are written out in a spiral. So there are variations on the periodic table, but why is this big old rectangle thing what we actually use? Well, there's this guy way back in the day called Mendeleev. And so what he did was he looked at the elements and he saw an order of kind of like relative mass, right? So he started to order his periodic table something like what you see on the left, this weird cream looking thing. So what's happening is he's starting to line them up by like relative mass, and there are some kind of blanks in the periodic table. So when he did this, he noticed that there was relatively kind of certain behaviors. So, like these ones all kind of behaved the same, these ones kind of behaved the same. These ones and these ones and these ones and these ones and these ones, they all kind of behaved the same, and he had some that he didn't quite know what to do with. So he let those properties and behaviors guide him as he was setting up the periodic table, and he ended up realizing that they basically could all be arranged by relative mass. So just as a small note, Mendeleev and another scientist with the last name Meyer kind of came up with this independently at the same time, kind of like what happened with calculus. But we know how history goes. Whoever publishes first in science gets all the credit, even if you came up with the same thing yourself. So Mendeleev gets all the credit, but I feel like Meyer deserves a little bit of shout out. When Mendeleev did this to the periodic table, again, he realized that there were repeating patterns of behavior, but it also left us with these gaps that are open where he could kind of fill it in and think, there must be an element there. So it kind of set out this duck hunt, shoot for the moon race between all of the scientists when Mendeleev published this, and they said, okay, cool, we're going to find all the missing elements. So scientists went nuts for a long time trying to get their name on the periodic table or get their element they discovered on the periodic table by filling in the gaps that were missing. And so this has been translated into our more modern day format over here, what you see on the right, that kind of typical shape you think of when you think of the periodic table. But if you'll notice, we have that first column here with hydrogen, lithium, sodium, potassium. Copper's not in that column, but neither is silver, but cesium's down there at the bottom. So he was close, but he wasn't all the way right. And that's why we've adjusted this. So now we have those repeating patterns of behavior, and we've kind of organized things in a tiny bit different of a way. So what we know now that Mendeleev was like on the verge of, he was like right there, is that we actually organized the periodic table by atomic number. So by that number of protons rather than the mass number. The mass numbers are very similar in most cases, and you can see that most of the periodic table follows that behavior where if you have a higher number of protons, you have a larger mass, but that's not always true. But if we arrange them by number of protons by that atomic number rather than the relative mass as Mendeleev did, we can find all of those patterns he was looking for. So he was right on the verge of it, but again, it is a little bit more now we know about the number of protons rather than relative mass, and so that's why you can see some of these shuffled around just a little bit. So let's talk a little bit about the type of elements that we see on the periodic table. So there are 3 different types of elements we're going to talk about. And the first that we'll discuss is metals. So metals are all on the left-hand side of the periodic table. They're this cream color that you see on your screen over here, except for hydrogen. You're going to hear me say that about 1.5 million times during this lecture, except for hydrogen, except for hydrogen, except for hydrogen. So hydrogen, in my mind, sometimes I kind of picture him over here by helium. There's a reason he's over here, and it has to do with that number of protons, and he behaves sometimes like this first column. However, hydrogen, it's a nonmetal. 9 times out of 10 in my head, I'm picturing it floating around somewhere over here instead of being on top of that column there. So again, metals are all on the left-hand side of the periodic table, except for hydrogen. Metals, as you may know, are good conductors of heat and electricity, right? Like you don't want to set a pan on the stove for like 5 minutes and try to pick that up by the pan part. No, you're going to get burnt, right? We know they also conduct electricity. You may have experienced that where you've touched a piece of electrified metal before. Holy crap, it never feels good. So they're good conductors of heat and electricity. Some other properties metals tend to have are that they're malleable, so they're shapeable. So this would be like oftentimes why we like to use gold and silver and platinum for rings, because we can shape them into a nice little circle and we can wear them on our body as jewelry, right? And metals are also ductile. So being ductile means something can be pulled into a thin wire. So not all substances can be pulled into wire the way that metals can be. And that has to do with some of their electronic structure. But we'll talk about that when we get to the next chapter. Of course, our favorite part about metals is that they're shiny, and they like set our little human lizard brains off, and they're like, oh, they're shiny, so cool. So not all metals are shiny, but most metals tend to be shiny. And when metals undergo chemical changes, they do tend to lose electrons. So they take on a positive charge, and they lose electrons to do that. Some metals you may be familiar with might be iron, magnesium, sodium. They're part of a healthy diet. So these metals all lie over here. Sodium's over here, magnesium's right next to it, and iron's over here in column number 8. So those are all about the metals. And again, they're going to be anything you find on the left-hand side of the periodic table. And then that also, to point out, does include those 2 rows of the lanthanides and actinides that sit at the bottom. Non-metals. So in contrast to the metals, the non-metals are pictured in blue over here. So all of these over here in these columns right here, those are going to be non-metals and hydrogen. All of these and hydrogen are considered to be non-metals. So non-metals tend to be poor conductors of heat and electricity, so they tend to be insulators rather than conductors. And they tend to gain electrons when undergoing chemical changes, okay? So they're going to take on a negative charge because they're adding electrons to themselves. It's kind of hard to nail down some of those properties, like what we talked about with metals, shiny, ductile, malleable, whatnot, because there are more varied properties overall in the nonmetals. We've got a lot less nonmetals, and they behave a lot different than each other than those metals do. Some metals or nonmetals that you may have heard of before: oxygen, what we use to breathe and live; nitrogen, also. When you breathe in, you're actually breathing in about 70% nitrogen from the air rather than just, we think about breathing in pure oxygen, but the air is a mix of lots of different things, and a lot of it is nitrogen. Chlorine, is actually, it's a nonmetal and it often exists as a gas, but you may be thinking about bleach or putting it in a pool to keep your pool nice and clean and sanitary. So chlorine's a nonmetal, and argon, so like argon gas, if you have heard of that. So those are all nonmetals. And the final group is called metalloids. So in some places, you may have heard metalloids called semiconductors, and that tends to be how they behave. But you'll always hear me call them metalloids. So they fall in these green ones right here. Oftentimes on a periodic table, what you'll see is that there is a darkened line separating the metalloids. Like it'll kind of follow a pattern like this. It steps down like this. Most periodic tables I will give you will have that line there. This one, the book just didn't. But they fall on that diagonal line that separates the metals from the nonmetals. And so metalloids are kind of like half and half. They've got a foot like through each door. They're like standing in the middle of the doorway like, hey, I behave like a metal sometimes. Hey, I can also behave like a nonmetal. It just depends on which way I lean today. So they kind of lie in the middle there. Intermediate, they have an intermediate level of electrical conductivity that can be controlled. So this is why you often hear that semiconductors are used in technology. It's because we can start and stop when we want electrons flowing through them. So we can control that level of conductivity for whatever purposes we are using them for. And metalloids have the most varied properties. While I said that those nonmetals were varied, holy crap, this teeny tiny group of elements, these nonmetals you see here, or these metalloids you see here in green, those have even more varied properties because of some of these things like the fact that they can be semiconductors. They can do lots of different things when you're able to control that level of electrical conductivity. Some you may have heard of before. Are silicon, right? We think about Silicon Valley, that's like the big one in tech is using silicon. Arsenic, that's a poison. You may have heard that before if you think about the musical Chicago, right? One of the 7 Mary murderesses of the Cook County Jail murders her husband with arsenic in his drink. Another one that you may have heard before, maybe not, is germanium. So we use this often in detection of radiation. So when I worked at the nuclear plant, if we wanted to determine how radioactive a sample was, we would use a germanium-based detector for that. So there are lots of different ways that you can, detect radiation, but germanium is one of them. So pretty cool. So I want you guys to be able to know what's a nonmetal, what's a metal, what's a metalloid, and I want you to generally know where they are on the periodic table, right? So again, I'll usually give you something that has a darkened line so you can kind of see where the metalloids are and you can follow them along their like little pathway there. But you should know for certain that the metals are on the left-hand side of the periodic table and the nonmetals are on the right-hand side of the periodic table. We could talk a little bit too about main group versus transition elements. So we can talk about the type of element and we can also talk about this main group versus transition space. So a main group element is an element that has the letter A at the end of its group number. So lots of periodic tables will label them like this with A's and B's. So main group elements are going to have A at the top of their column, and they're going to be the first 2 columns. So the column with hydrogen, the column with beryllium, and then they're going to be all 6 of the last 6 columns, all 6 of those. So the ones with boron, carbon, nitrogen, oxygen, fluorine, and helium. So they're basically kind of the parts of the periodic table that stick up off the top. That's where you're going to find the main group elements. So main group elements, why we care about this is because they kind of behave a little bit differently than a lot of the stuff there in the center. And 9 times out of 10, when we're dealing with things, you'll notice that we're mostly dealing with main group elements. So like all of the elements of life are considered main group. They're like, you know, carbon, nitrogen, oxygen. You might find some sulfur, phosphorus, silicon in there as well. You'll find that they are the main suspects for metals that we'll come across. So what I want you to take away from this is that you should be able to tell me whether elements are main group elements or whether they're transition elements. So the transition elements are wild boys. They behave all crazy like all the time. But the main group elements are kind of our main suspects. They're like kind of the ones that you'll become familiar with throughout the semester because we're going to use them all the stinking time. Okay? So you should be able to identify a main group element versus a transition element. So last but not least here, let's talk about families, okay? So we first talked about the type of atom or type of element we have being metal, nonmetal, metalloid. We've talked a bit about main group elements, so main group versus transition. And now the last thing you kind of need to know about locations on the periodic table are families, okay? So we're going to talk a little bit about families here. So families are groups of elements that have extremely similar properties. So these are all going to be columns on the periodic table. So when we finally lined up all those elements by their number of protons, boom, this happened, and we ended up with these families that have extremely similar behaviors. So it's one of the reasons why it's so useful that we set our periodic table up this way. So that first column you see here, minus hydrogen, because always minus hydrogen, right? So the first column, minus hydrogen up here, so starting with lithium and on downwards, we call those the alkali metals. So they are very reactive. Oh my goodness. They are some of like my favorite things to watch react. I haven't ever, okay, I've seen sodium metal and maybe potassium metal react with water in person, but once you get beyond that, as you start to continue to go down the periodic table, they like explode and go nuts when they hit water. I've linked a video to some of those chemical reactions there where they take lithium, then they take sodium, then they take potassium, and so on and so forth. They add them all to different amounts of water. So you can see how those react with water. Highly recommend, really cool. You get to watch stuff blow up. So go check that out and see how exactly reactive those alkali metals are with water. Those are always going to be group 1A, that first group there. So the very far left-hand column, we call those the alkali metals. The second column, not to be confused, is called the alkaline earth metals. So we have the alkali metals, and then we have the alkaline earth metals, okay? A little confusing, but you gotta kind of keep them straight. So that's gonna be everything in group 2. These are also very reactive. They're not as reactive, but they're also very reactive with water. And a lot of the stuff in the alkali metals and the alkaline earth metals are kind of used in fireworks to color fireworks, because that's another property of metals is they can give off a color when they're lit on fire. So magnesium is an alkaline earth metal. We talked a little bit about it before. You may be familiar with it. It burns a really, really, really bright white. Like you can't look at it. Like when we burn it in lab, if you've ever burned magnesium in lab, you can't look at it. You got to like kind of peek out of the corner of your eye, kind of like, you know, welders can't look at directly what they're doing. We cannot look directly at magnesium either. And then calcium is another alkaline earth metal, and that one burns bright. Well, not really bright red, but red, like deep, deep red. So. Just a little bit about the alkaline earth metals. So we have the alkali metals in the left-hand column here, and we have the alkaline earth metals in column 2. So the other two families we're going to talk about are on the right-hand side of the periodic table of the nonmetals. So the halogens are going to be right here in group 7A or group 17 here, it's listed. So this one right here, these are the halogens, okay? So they're very reactive nonmetals. You will find that a lot of times when we're talking about things throughout the semester, oh boy, are we going to constantly be talking about the halogens. We talk about the halogens, carbon, nitrogen, and oxygen. Like they're always there. They're always there. So they're going to be very reactive. They like to hang out. They like to do stuff. So there are those there. Some you may have heard of, again, fluorine. We put that in our water to help protect our teeth. Chlorine, again, we put it in our pools for sanitation purposes. Iodine is actually used in the case of like a nuclear accident because a lot of the radiation can damage your thyroid. So I know that there are plans that if the nuclear plant ever has an issue, ever has a meltdown, they have plans to distribute iodine to the community to help the community protect their thyroids. So they're pretty reactive. They have lots of different uses, and those are just a few and a couple there. The last family we're going to talk about in this class is going to be the noble gases. So these are the noble gases all the way over here on the right. Let me get out of the way here. So it might be group 18, or we might call that group 8A. Those are the noble gases, right? So the noble gases, what's notable about them is like they are not reactive. Like it takes so much coercion, so much effort, so much everything to get a noble gas to react, okay? So the thing is like noble gases are not reactive. And you know, that's why they're called noble gases, right? So noble gases are not reactive. And so if you think about it, if you think about the concept of like nobility in the Middle Ages, I guess we still have nobles now, like in Britain, right? We have the Queen. But if you think about it, you know, it's like the royalty, the dukes and duchesses and whatnot are the nobility, right? And so the nobility don't interact with the general masses. So that's why these are called the noble gases, because they don't react. They aren't hanging out with all of these people over here, all these peasants on the rest of the periodic table. The noble gases aren't having it. They're not reacting. They are perfect the way they are, and they will let you know. So anyways, you may have heard of helium before, right? We fill balloons with helium, and that is less dense than most of the air we deal with, so that's why those balloons rise. You may have also heard of neon. So neon is another noble gas, and we often have neon lights, right? The kind of cool signs that you might see in a downtown. Kind of makes me think of the 80s kind of a deal. So neon is a noble gas as well. And krypton. Krypton's another one. It's not just a Superman reference. Krypton is actually a noble gas. So they kind of got the name there from periodic table. So pretty cool. So that's just a little bit about some of the information I want you to know about where things are located on the periodic table and how we can use the periodic table as a tool and a resource when thinking through these things. So what you need to know is the types of elements, where they're located on the periodic table. So metals on the left, metalloids in the middle, nonmetals, and hydrogen. Well, hydrogen is a nonmetal, but hydrogen and the nonmetals are on the right-hand side of the periodic table. We have our main group and our transition elements. So our main group elements are all those tall columns. So the first two and the last six, all the really tall columns. Everything else is going to be considered a transition element. And then we need to know the families. So you got to know that these are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. So in the next video, I'm going to talk a little bit about ions, and the next one will be isotopes, and the following will be atomic mass. So there you go.